Welcome back to space, 6th grade. All right, properties of Earth. This is chapter 23, lesson 1. So Earth's shape. It is a sphere, fancy name for a ball. A round 3D shape, whose center point is the same distance from all the points on its surface. How and who decided the shape? We would say God, but Aristotle is the one that figured it out in 350 BC. How did he do this? Not like he could go up in a space shuttle. Well, he saw a curved shadow on the moon during a lunar eclipse. So he thought, the Earth is casting that shadow. If there's a curved shape, the Earth must have curve. Sailors also did this. Watching this video that'll be linked into the other one, it just kind of shows how the prow of a ship, the very top comes up first, and then you see the bottom from a long distance away. So that also showed that the Earth was round. We saw the tops of ships before the bottoms. Page 660 is a good example of that. And also the position of the stars changed as they sailed north or south. So they had to realize, oh, we're looking up at different angles. That would mean a curved item. Nowadays, we know from satellites and space probes that we do have those. Pictures of Earth are round. All right? So Earth's axis and rotation. This is important because it helps determine, like the Bible says, our days and months and years. The axis, the imaginary line around which Earth spins. This is the axis of rotation. That line, and it spins around there. All right? Whoopsie. Backwards. Rotation on its axis causes the spinning of the Earth. And the spinning of the Earth causes it to rotate once every 24 hours. So rotating on its axis causes us to have day and night and causes 24 hours to be the time for one day. Rotation on its axis causes day and night. Important to remember that. Us spinning around that circle causes day and night. Oh, sun's over here. This side facing it is day. This side facing away is in shadow. Night. All right, nice little video there. It'll be linked in as well. Orbiting the sun. Revolution. One time around. Oh, that point in the center, revolving or a revolution around there, that is there. Earth's yearly orbit around the sun. It happens in a 12-month cycle. It is what causes us to have the revolution plus the tilt, causes us to have our seasons. These two videos will also be linked in. All right. Solstice. The point at which the sun reaches the greatest distance north or south. You know, we've heard about the longest day of the year and the shortest day of the year. These happen on the solstices, okay? The summer solstice is June and December. How can that be? Because in June, it's at the highest point north here in our northern hemisphere. Oh. But in December, it's a highest point south. Winter solstice is June and December. How? Northern and southern hemispheres have opposite seasons. When we're pointing towards the sun, they're tilting away from the sun. All right? Daylight hours are longest when pointed toward the sun, like this, or if you're in the southern hemisphere, like this in December, and the shortest when they're pointed away. So in June, they're pointed away, they're having their winter. In December, they're pointed towards, they're having their summer. In December, we're pointed away, we're tilted away, we're having our winter. In June, we're tilted towards, we're having our summer. Equinoxes. Point at which the sun is directly over the equator. March, September, our fall and spring. The spring equinox is in March. Hey, sun's right at that middle. And September. The fall is in March and September. Because in March, we're at the equinox. And they're at the equinox. September, same thing. The hours of daylight and night are equal. A video that will hopefully help explain it a little bit. These videos are key. Do take the time to watch them. Pop quiz. When it is spring, when is it spring? When the sun is directly over the equator. So it could be spring in March or September. How could it be both? When is it fall? When the sun is directly over the equator. It could be March or it could be September, depending on which hemisphere you're in. When is it summer? When your hemisphere is tilted toward the sun. For us, it's June, we're tilted toward the sun. For them, it's December, they're tilted towards the sun. When is it winter? Same thing. In June, it's winter for them, they're tilted away. December, it's winter for us, we're tilted away. What month is summer in the northern hemisphere? North. June, we're pointed towards the sun. What month is winter in the southern hemisphere? Winter. Winter in the southern. June! That's when they're pointed away. And it's opposite for them. December is summer for them and winter for us. Again, another video. Earth's elliptical orbit. What month would you guess the Earth is closest to the sun? If you're like me when I first did this, you'd be wrong. In July, we are actually further away from the sun by a small amount due to space-time, or in space distances. And in January, we're closest. Earth's orbit is an ellipse or an elongated circle. What two factors cause the season? Earth revolving around the sun and the tilt of Earth on its axis. Now, Earth's magnetic field, is the geographic North Pole and the North Pole the same place? The answer to this question while you read page 662. Spoiler alert, they're not. But why not? Bye, guys. Have a good one. All those videos are important.